Today we're going to talk about box and whisker plots, which I think get a bad rap. I think they're super fun. It's all about finding the median, which is the middle number. And essentially, a box and whisker plot is going to organize our data into 4 groups called quartiles. Ordered data are divided into what's called lower and upper halves by the median. And then the median of the lower half is called the lower quartile. And the median of the upper half is called the upper quartile. And a value, I skipped one. And then we're going to talk about this year the interquartile range is the difference of the upper and the lower quartile. And then a value that is widely separated from the rest of our data is what we can call an outlier. So the first step every single time, okay, is to put our numbers in order. So let's look at example number 1. It says several brands of ready-to-eat cereals were compared. The number of calories in a serving of dry cereal for each brand is listed below. Make a box and whisker plot of the data. Identify the interquartile range. So let's start with number 1. First thing we need to do is put our numbers in order. So the smallest number that I see is 132, then 141, then I have 153, 155, 165, 172, 180, 191, let's see what's next, 200, 220, just kidding, 213 first, and then 220, 213, and then 220. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, which let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I have 11, is there going to be one that's stuck in the middle? Like if I were to divide them into groups, is there going to be one person left out in the middle? Yes, it's going to be number 6, right? 1, 2, 3, 4, 5, middle, 1, 2, 3, 4, 5, middle. So 172 is our median. Okay, 172 is our median. So now I'm going to look at this lower half of the data. I have 5 numbers. Is there going to be an exact middle? Yes, 153, right? Not middle. And then the upper half, 1, 2, 3, 4, 5. My third number is going to be my middle. So now that I have that, I'm going to draw a number line. Okay, my number line has to go from 130 to 220. So I'm just going to count by tens. I have 130, 140, 50, 60, 70, 80, 90, 200, 10, 20, 30, 40, 50. I went too much, but that's okay. It doesn't matter. So I am going to graph, first thing, my lower quartile. So 130, 140, 150. So in between 150 and 160, this line, I'm going to write the number on top. Okay, it's 153. Then I'm going to graph my median, which is 172. So 130, 140, 50, 60, 70, so a little more. And I'm going to write my number on top. And then 200, I'm going to write it on top. Okay, and then we're going to, I went a little bit wonky there. Okay, so that is my box with my lower quartile, median, and upper quartile. And so now I'm going to do my whiskers, which are 132, my lowest number, and 220, my highest number. So 200, 10, 20. So again, I did not need to include all of this on my number line. I just kind of messed up. And then what you're going to be asked to find on your homework is the interquartile range, which is the difference between our upper quartile, which is 200, minus my lower quartile, which is 153. And when you subtract that, you can't even see it, we get 47. Okay, let's look at example number 2. It says, cords and junk everywhere here. Okay, on number 2, make a box and whisker plot of the heights in centimeters of 9 seedling oak trees and identify the interquartile range. So I'm going to put my numbers in order. If you want to pause it and put yours in order and then check, you can. But what you should end up with is 17, 18, 21, 24, 28, 29, 32, 35, and 41. Okay, those are our numbers in order. So there's 9 numbers, 5, 6, 7, 8, 9. So is there going to be an exact middle? Yes, it's going to be 28, right? That is my median. So now I'm looking at this lower half of the data and I need to find the median. Is there an exact middle? No, it's going to come right in between 18 and 21. So if I add that together, 18 and 21, I get 39 divided by 2 means that my lower quartile is 19.5. Now I look at these 4, and if I divide it in half, the median would come right in between 32 and 35, which is 33.5. If you don't know how I'm getting those numbers, I'm just finding the average or the mean of those two. So 32 plus 32 plus 35 divided by, y'all, I can't see the calculator when I'm doing this. I have to look on my phone screen and I'm having a hard time. Divided by 2, 33.5. So now I'm going to take my data, I'm going to put it on a number line that needs to go from 17 up through 40. So I'm just going to go 10, 20, 30, 40. And I'm going to put little tick marks in between to represent the 5s. Oops, you can't even see that. But that represents, or there is my number line. I'm on the struggle bus with this one. There we go. Okay, that has all my numbers from 10 through 40. So I'm going to graph my lower quartile, 19.5. So there's my line, and I write 19.5. My median is 28. So in between 25 and 30, and then 33.5, so almost at 35. So there's my lower quartile, my median, and my upper quartile. Now I'm going to graph my lowest number, which was 17, and my highest number, which was 41. And then if it asks you for the interquartile range, it's my upper quartile minus my lower quartile. So 33.5 minus 19.5 is 14. There you go. Okay, and the quartiles, I'm not sure if I went into detail about this, but it's dividing it up into quarters. So like 1/4 of my data is below 19.5. Half of my data items are below 28, right? So would it be correct to say 75% of the oak trees were taller than 19.5? Yes, right? So 19.5, 3/4 of them, right? This is a quarter. 1, 2, 3/4 are above 19.5. Okay, and then the last example, example 3, we're going to go ahead and put them in order. So if you want to pause it, that's fine. And let's see. Let's put them in order. We should have 188, 192, 224, 225, 239, 271, 275, 286, 316, and 334. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So it's going to go 1, 2, 3, 4, 5 median, right? What would come in between 239 and 271? Well, we can add them together, which gives us 510, and then divided by 2 is 255. Okay, all I did on a calculator, 239 plus 271, 510 divided by 2, 255. Okay, and then we're going to find the lower quartile. And so there's 1, 2, 3, 4, 5 numbers. So my middle would be 3. 1, 2, 3, 4, 5. My middle would be 286. So on my number line, I have to go from, my lowest is 188. My biggest is, what is that, 330. So I'm just going to go, let's see, 190, 200, 210, 20, 30, 40, 250, 60, 70, 80, 90, 300, 10, 20, 30, 40, 50. Okay, and let's go ahead and graph our lower quartile, which would be 224. So 250, 240, 230, 224. And then 255, so in between 250 and 260. And then 286, so 50, 60, 70, 80, 90, so in between. And again, we're writing our numbers on top so that I know that you got them correct. Then my lowest is 188, so below 190. My highest is 334, so in between 330 and 340. Just like that. And if I asked you to find the interquartile range, 286 minus 224, upper quartile minus lower quartile is 62. And then the last part is just making kind of what I was talking about a minute ago. It says the box and whisker plot shows the number of American goldfinches sighted each month for a year at 2 different wildlife reserves. Okay, so there must have been 12 data items, right? And we are counting how many goldfinches they saw every month at Reserve 1 and Reserve 2. So it says for how many months is Reserve 2's count? At least 17 birds. So that would be all of this data and all of this data, right? Well, if 1 year equals 12 months, then I know, well, 2/4 of it were more than 17. That's a half. So that's 6 months. Okay, it says compare the count in Reserve 1 to the count in Reserve 2. So what can you tell about the counts in Reserve 1 and Reserve 2? Reserve 1 had more birds. Reserve 1 observed more finches or more birds, right? Just looking at it, half of their months they saw 25 or more, right? And their lowest was 8, their highest was 33. Overall, their whole data set was farther to the right, was greater than Reserve 2. Okay, for how many months was the count lower than 11 at Reserve 2? So here's 11. Lower than 11 is 1/4. So that would be 3 months. And then letter D, for how many months was the count at least 19? So 1/4, 2/4, 3/4. So that would be 9 months.